Next one, coefficient of fluctuation of speed. So C means coefficient means C. So fluctuation of speed is CS, and the coefficient of fluctuation of energy means CE. Right? So don't get confused. So coefficient means C, notation C. Coefficient of fluctuation speed means CS. Coefficient of fluctuation of energy CE. Right? So the difference between the maximum and the minimum speeds during a cycle is called the maximum fluctuation of fluctuation of speed. The difference between the maximum and minimum speed during a cycle is called the maximum fluctuation of speed. The ratio of the maximum fluctuation of speed to the mean speed is called the coefficient of fluctuation of speed. Is formula is Cs equal to n1 minus n2 divided by n, and n equal to maximum speed and n2 equal to minimum speed. Okay, so equal to 2 into, so but we know the formula n equal to n1 plus n2 divided by 2. Okay, so it's is equal to n1 minus n2 divided by n. So next one, energy stored in a flywheel. So this is a flywheel rim, outer rim. It is a radius from up to inner wheel. So it is a eta. So when a flywheel absorbs the energy, its speed increases, and when it gives up, the speed is decreases. Right? So wheels is rotating, so it's a split or fuel will be separated. No, uh, fuel means separated means it absorbs the energy, so the speed will be increases. Then it is no load or no fuel means no supply of energy means it will releases energy and the speed will be reduces. So let m equal to mass of the flywheel in kilogram. So weight of the mass. So flywheel it has some mass less. So mass of the flywheel in kg, and k equal to radius of gyration of flywheel in meters. So radius of gyration nothing but it's a radial distance from the outer area, right? So radius of gyration, and I equal to mass moment of inertia of the flywheel about its axis of rotation kilogram meter square. So already you studied in engineering mechanics moment of inertia, right? So n1 and n2 equal to maximum and minimum speed during the cycle in rpm, and omega 1 equal and omega 2 equal to maximum and minimum angular speed during the cycle in radian per second. Right? So n equal to mean n equal n equal to mean speed during the cycle in rpm. So n order formula. So n1 plus n2 divided by 2, and omega equal to mean angular speed during the cycle in radian per second. So omega 1 plus omega 2 divided by 2, and c is equal to coefficient of fluctuation of speed. So n1 minus n2 divided by n, or omega 1 minus omega 2 divided by omega. So for example, so this is in terms of speed, n equal to in speed of speed. So omega means in terms of angular speed. Okay, angular in case of v1 minus v2 divided by v, it is called in terms of linear velocity. Right? So C's formula we can write in three method. So first one n1 minus n2 divided by n. It is a coefficient of fluctuation of speed in terms of speed, and yeah, or the omega 1 minus omega 2 divided by omega is in terms of angular velocity, and v1 minus v2 divided by v in terms of linear velocity. Now, so maximum fluctuation of energy delta E equal to maximum fluctuation of energy delta E equal to formula I omega square Cs. So this is a formula, but we know we have, so moment of inertia already we discussed in this slide. So I equal to mk square. I equal to I for I value, I means mass moment of inertia. I or formula mk square, where k equal to radius of gyration and m equal to mass of the flywheel. Right? Mass of the flywheel. Now substitute I formula I equal to m into k square omega square cs. Omega square cs. This is a formula. Right? So now, so delta E equal to m r square omega square cs. So same formula. So in this formula mk square omega square cs. So in terms of instead of k, okay, r will be supplied. R will be a substitute. So k means k radius of gyration. So instead of k, okay, so r value. So that is a flywheel ring or radius of the flywheel ring. Okay, so in terms of radius of the flywheel ring. So delta E equal to m r square omega square cs. Okay, so now where v equal to omega r above in the m cs is cs, right? So now r omega and r omega means what v. So both are it's a square so that v square. So that v square. So delta E equal to, so it's one formula and one more formula in terms of speed. So there is a delta E equal to pi square divided by 900 into m into k square n into n1 minus n2. So where delta E equal to maximum fluctuation of energy and m equal to mass of the flywheel and k equal to radius of gyration and n equal to mean speed and n equal to maximum speed and n2 equal to, sorry, n1 equal to minimum speed and n2 equal to, sorry, n1 equal to maximum speed and n2 equal to minimum speed. This is a formula ma. So first for problem number one, problem number one, problem number one, the mass of the flywheel of an engine is 6.5 tons and the radius of gyration is 1.8 meter. It is found from the turning moment diagram that the fluctuation of energy is 56 Newton meter. 56 kilonewton meter. If the mean speed of the engine is 120 rpm, 120 rpm, find the maximum and the minimum speed. So maximum means n1 and a minimum n2. Okay, speeds respectively. Okay, so we are going to solve the problem here. So mass means mmoma. Okay, don't forget. So mass of the flywheel, mass m equal to eta. So 6.5 ton. Solution, mass m equal to, okay, solution given m equal to mass. Mass means mass m, notation letter m equal to 6.5 tons. So we know, so 1000 kilogram it is equal to 1 ton, right? But so tons in terms of ton into kilogram we want. So every value we have to substitute in terms of SI units, right? So mass means for mass SI units kg. Okay, it is given ton in terms of ton, so that we have to convert into ton into 6.5 ton into kilogram. So okay, how we can convert? So multiplied by 1000, right? So 1000 kilogram into is equal to 1 ton. So that, so 6.5 into, so 6.5 into 1000 is equal to 6500 kilogram. So next, radius of gyration. Radius of gyration means K. So don't forget the symbol. So in this unit, so simply, so not only in this unit, so yes, all the subject, all the units. So don't forget the units and notation letters. Okay, done. So don't forget. So radius of gyration K. K is 1.58 meters. Okay. So in case of if it is given by mm, no, we have to convert into into meter. Right? So next, it is found from the turning moment diagram that fluctuation of energy. Fluctuation of energy means delta E, or maximum fluctuation of energy, or fluctuation of energy delta E equal to 56 kilonewton meter. So 50, delta E equal to 56 kilonewton meter. But we want only newton meter. Right? So energy delta energy newton meter. There is a torque. Right? So that 56 into kilo value, k value 10 power 3, k value 10 power 3. K value 10 power 3. So 56 into 10 power 3 Newton meter. And finally, speed, mean speed. Right? If the mean speed, if the mean speed is given, mean speed means n, capital only n, capital only n. Right? So n1 means maximum speed and n2 equal to minimum speed. But here mean speed means n. So n equal to 1000 to 120. So 120 or so n equal to 120 rpm. Right, given. So we have to find out finally. So n1 and n2, that is maximum and minimum speeds respectively. So now we know the formula delta E. So we know that fluctuation of energy or maximum fluctuation energy delta E equal to, substitute this formula. So this substitute this formula. So delta equal to pi square by 1000. So pi square by 900 into m k square n into n1 minus n2. Substitute the formula. So on the delta, write the formula and substitute the value, known value. So delta E value given 56 into 10 power 3 Newton meter into equal to pi square by 900 into m k square n into n minus 1. Right? So pi square by 900. So m value, mass value is given. Sorry, given 6,500, 6,500. And k its radius of gyration 1.8 given 1.8 k square. So 1.8 k square into n, capital N value 120. So 120 is substitute 120 value and N1 minus N2. Formula N1 minus N2 is there. So that is both N1 and N2 values unknown value. So this is what we are going to find out. So now, so simplify, we can get, so can take calculator and do it. So type it pi square divided by 900 into 6500 into 1.8 square into 120. After simplify, you will get 27,000. Okay, ma. So after you will get 27,715 into neat 1 N1 minus N2. Right? So N1 and N1 minus N2 equal to, so here, so you see ma. So here one value 56 into 10 power 3 is there, right? So 56 into 10 power 3 is there. So equal to 27,715. Right? Into N1 minus N2. So if you want N1 minus N2 now, so bring that side. So it divided by, so 56 into 10 power 3 divided by 56 into 10 power 3 divided by 27,715. 27,715. So finally we will get value of 2 RPM. So that is N1 minus N2. N1 minus N2 now. So we know the formula N equal to, N equal to N1 plus N2 divided by 2. So N1 value and N plus N2 value unknown value. But this N value we know, right? So this N1 value we know. So N equal to N1 plus N2. N value substitute 120. So N1 plus N2 divided by 2. So 2 into 120 or 140. Sorry, 240. So N1 plus N2 equal to 240 RPM, right? So equation number 1. So what is the equation? What is the equation number 1? So N1 minus N2 equal to 2 RPM. But equation number 2, N1 plus N2 equal to 240 RPM. So simplify, we will get finally, so N1 equal to 121 RPM and N2 equal to 119 RPM. Clear? Anyone please respond. Clear, ma? Is it clear?
Yes, sir.
Yes, sir.
Okay, ma. Just simple, ma. Simple. Just a formula and substituting. Right? Simple. Don't forget the units and the notations later. Okay. Radius of gyration is a K. Mass means a M. Delta E, maximum fluctuation of energy or fluctuation of energy in the formula. So next problem. A horizontal cross compound steam engine develops 300 kilowatt at 90 RPM. The coefficient of fluctuation of energy as found from the turning moment diagram is to be 0.1 and the fluctuation of speed is to be kept within 0 plus or minus 0.5. Okay, plus or minus 0.5 percentage of the mean speed. Find the weight of the flywheel required if the radius of gyration is 2 meters. Right? So here the okay, ma. So here steam engine develops 30 kilowatt. So power is given P equal to 300 kilowatt. So we already SI units only watt. So kilo value 10 power 3 is 300 into 10 power 3. So N value, so at speed value N 90 RPM given. So N equal to 90 RPM and the coefficient of fluctuation of energy CE. So only just simple fluctuation of energy or maximum fluctuation of energy means delta E. But coefficient of fluctuation of energy into the coefficient means C. Right? Fluctuation of energy C equal to 0.1. So it is given 0. The coefficient of fluctuation of energy found at any moment is to be 0.1 and the fluctuation of speed kept within 0 point, plus or minus 0.5 of the mean speed. Find the weight of the flywheel. So weight of the mass, we have so far we discussed mass of the flywheel, right? Mass of the flywheel only we discuss, but here weight is asking. So weight means so mass into gravitational force. So it will be converted into weight. Simple, correct? So that so k value, k is the radius of gyrations given ma. Radius of gyrations 2 is given, right? So now we know that the mean angular speed omega equal to n value is given ma. So that by using n value, we have find omega equal to 2 pi n divided by 60 is equal to 2 pi n value substitute பண்ணுங்க 90 divided by 60 is equal to 9.426 radian per second. So where omega 1 and omega 2 equal to maximum and minimum speed respectively. So now fluctuation of speed and already we discussed in turning mode diagram. So it is a mean torque, right? So it is a mean torque line. So fluctuation, so plus minus, right? Okay, so up this curve will be lies on the up now, so positive plus. So if it is a lies on the below na minus, so it is a plus, it is a minus, right? So that the fluctuation, so fluctuation within 0.5% means, okay, up in up 0.5 and below 0.5, right? Above the mean torque, simple so it is a line mean torque line, right? So it is above and below the mean torque line, so that is called fluctuation of energy, fluctuation of speed, right? So in this, it is a mean torque na, so up to here 0.5, right? By below 0.5, totally 0.5 plus 0.5 1, right? So that fluctuation of speed omega 1 minus omega 2 equal to 1 percentage of omega means speed la omega, so omega equal to 0.1% le. So 1% is 0.00 omega. So coefficient of fluctuation of speed C is equal to omega 1 minus omega 2 divided by omega. So omega 1 minus omega 2 value 0.01. Right? Omega value 0.0 C. Omega minus omega 1 or omega 1 minus omega 2 value 0.01 omega. 0.01 omega. So divided by here 1 omega. So omega omega cancel, remaining 0.0101 only will come. Right? So we know that the work done per cycle equal to work done W equal to P into 60 divided by N is equal to work done is given, right? So work done 300 into 300 to 10 power 3 into 60 divided by 90. 360 divided by 90 is equal to 200. So or to simplify, we will get 200 into 10 power 3 Newton meter. So now come to maximum fluctuation of energy D equal to work done per cycle into C. So work done per cycle value 200 into 10 power 3 into C value 0.1. So finally, after simplify, we will get is 20 into 10 power 3 Newton meter. So now we are going to find out, we have to find out mass of the flywheel. So mass of the flywheel means, so what is the relevant formula for the for finding the mass value, right? So relevant formula for mass, so delta E only. Delta E equal to m into k square omega square cs. Okay, this is the formula. So delta E value, we found that, right? So we found that, so 20 into 10 power 3. So substitute 20 into 10 power 3 here, right? Here, uh, here, and is equal to, so m value, that is what unknown value we are going to find out, and k value 2 square into omega square, omega value 9.426 omega whole square into omega square, cs value 0.01 is equal to finally 3.554. Okay, so m equal to 20 into 10 power 3 divided by 3.554 equal to 5630 kilogram. Okay, so it is a mass. So from mass we will convert into weight. That's our mass value into 9.81. So that is weight. Now, so it is a very important problem. So first two problem, uh, that is for a simple and understanding purpose. So this problem only important repeated questions in the exam point of view. Right? So listen carefully. The turning moment diagram for petrol engine is drawn to the following scales. Turning moment diagram for the petrol engine. A petrol engine is drawn to the following scales. We know more. Once again, I repeat. Please, okay. So once again, repeat. So turning moment diagram. Don't forget. Okay, so turning moment diagram is nothing but is a crank effort diagram. It's a graphical representation of the turning moment under the crank angle. Right? So when x-axis crank angle and y-axis turning moment. So the turning moment diagram is nothing. It's also known as crank effort diagram. So the crank moment of the crank, okay, that is the recurrent crank effort with respect to the crank angle. So, for example, particular angle 10 degree means, so what will be the position of the crank angle? Crank, what will be the position of the crank? So, there and the another 20 degree and another 40, 60, 80, 90 and all. So, what will be the position of the crank? Simple. This is definitely the power fluctuations. Okay, the speed fluctuation will be there. So, this is what we are going to find out. So the turning moment diagram for petrol engines drawn to the following sketch. Turning moment, okay, 1 mm is equal to 5 Newton meter. So note down clearly. So 1 mm equal to 5 Newton meter. Crank angle 1 mm equal to 1 degree. So it is a scale conversion is very important. So while we turn from first unit, velocity diagram, velocity diagram. So velocity diagram, incident in center method, relative method. Okay, this is the first unit and third unit cam profile. So every any diagram you drawn with respect to the subject. So scale conversion is very important. Right? So the 1 mm equal to 5 Newton meter. This is for turning. This is turning moment. The crank angle 1 mm equal to 1 degree. 1 mm equal to 1 degree is given. So the turning moment diagram must repeat itself at every half revolution of the engine and the areas above and below the mean turning moment line taken in order are 295, 685, 40, 340, 960, 270 mm square. The rotating parts are equivalent to a mass of 36 kg at a radius of gyration of 150 mm. So determine the coefficient of fluctuation of speed. CS is asking. So when the engine runs at 1800 rpm. So what is the get data are given? So mass value given up. So mass value 36 kilogram. So mass value where so the rotating parts are equivalent to a mass of 36 kilogram. And K radius of gyration K value 150 mm given. So mm into meter. So divided by 1000 0.15 meter. So and N equal to and N speed equal to 1800 rpm given. N equal to 1800 rpm. Right? R so an annual is given. So from that we will find omega. Omega equal to omega formula 2 pi n divided by 60. 2 pi n value 1800 divided by 60 equal to 188.52 radian per second. Radian per second. This is omega value. So see the diagram carefully. So on horizontal axis crank angle and y axis and vertical axis turning moment. Right? So and the A B point, the center line, okay, that is called a T mean torque or mean torque. Right? So the 295 to 685, 40, 340, 960 and 270. So these are all the fluctuation of the fluctuation of the energy. Right? So fluctuation of energy, this is a 295, 685 in this. So from this we are going to find out the determine the coefficient of fluctuation of the speed. CS we are going to find out. So from this diagram we can going to find out. Since it, uh, since the turning moment scale is 1 mm is equal to 5 Newton meter and the crank angle and the crank angle 1 mm equal to 1 degree. So 1 degree means already many time we discuss. So degree into radian only multiplied by pi by 180. Okay. So degree, if you want convert from degree into radian, degree into radian, no? So multiplied by pi by 180 radian. Therefore, so 1 mm square on turning moment diagram is equal to 5 into pi by 180. Pi by 180 is equal to pi by 36 Newton meter. Okay, don't confuse. Okay, don't get confused, ma. So since turning moment scale 1 mm is given la kuthirukanga ma 1 mm equal to 5 Newton meter. listen. So turning moment 1 mm equal to 5 Newton meter and crank angle 1 mm equal to 1 degree. Okay, va. So 1 mm on 1 mm square on turning moment diagram equal to 5 into pi by 180. 5 into pi by 180. So is equal to pi into 36. So on the turning moment into uh, crank angle we have to multiply it. So m into 5 into 5 by 180, right? So equal to, once again ma. Okay ma. So pi by 36 Newton meter. So that let the total energy at A equal to E. Then referring to figure above figure, right? So E means energy ma. So at starting point A, starting point A. So imagine this, consider this diagram. So A point, so the well energy will be there. So that is if at G normal E energy. So there will be no value. So only energy at point A, right? At point B. So where is point B? So here point B. So what will be? So here energy at B. So B value E plus 295. E plus 295. Once again repeat. So point A will, so in the point now just it has some energy, but not value is the energy. A point like B. A point like E. The come to while come to B, so previous add the previous values. So in the A or E, A value plus 295. So y plus no, so it is a positive loop. So above the line no plus, below the line no minus. Right? So B equal to E plus 295. While coming at energy at C, E plus 299 minus 685. Okay, listen. So at point C now, so add the previous values. So E, E, here one E plus 295 minus 685. Because of 685, it's a below the line, right? Minus 685. Okay, minus 685 is equal to, இது அப்படி சிம்பிளிஃபை பண்ணலாம். சி ஈக்குவல் டு இ பிளஸ் 295 மைனஸ் 685. ஸோ 295 மைனஸ் 685 மைனஸ் 390 வரும். ஸோ அப்போ இ மைனஸ் 390. ஸோ சிமிலர்லி எனர்ஜி அட் பாயிண்ட் டி. டி பாயிண்ட்ல என்ன வரும் பாருங்க. ஸோ டி பாயிண்ட்ல என்ன வரும் பாருங்க. இங்க ஒரு இயா இ பிளஸ் 295 மைனஸ் 385 minus 685 plus 40. So this is called point D. Right? So point E minus 390 plus 40. So நீங்க previous value எடுத்துக்கலாம். So அப்ப simplify பண்ணோம்னா E minus 350. So similarly, so previous value தானே. So energy at point E. So well, find previous value E minus 35 350 E minus 350. So minus 340. So minus 340 இங்க down இருக்கும் minus 340. So minus 340. So simply, so E equal to E minus 350 minus 340. So minus 690. Return. So now energy at F equal to E minus 690 plus 960 equal to E plus 270. So E minus 690 plus 960. 270 energy at G. So G E plus 270 minus 270 is equal to E at energy E. Return. So நம்ம A பாயிண்ட்ல எங்க ஸ்டார்ட் ஆச்சோ அதே அதே பாயிண்ட் என்ன ஒண்ணுன்னா ஜி வந்து ஜி பாயிண்ட்ல அகைன் ஈல வந்துடும், ரைட்டா? அப்போ வரும். ஸோ இது வந்து இப்படி ரொட்டேட் ஆகுது. இந்த வீல் இங்கே சென்டர் பாயிண்ட் ரொட்டேட் ஆகுதுன்னா, ஸோ எங்கே ஸ்டார்ட் ஆகுது அங்கே தானே வந்து ஒரு ரெவல்யூஷன் முடியணும். ஓகேவா? ஸோ வேர் இட் இஸ் கெட்டிங் ஸ்டார்டட் அகைன் இட் கம்ப்ளீட்டட் இன் ரெவல்யூஷன் த சேம் பாயிண்ட், ரைட்டா? கெட்டிங் கம்ப்ளீட் ரெவல்யூஷன் அட் இன் த சேம் பாயிண்ட். ஸோ தட் இங்கே இன்னா, ஸோ இயர் ஆல்சோ இ, ரைட்டா? இயர் ஆல்சோ இ அட் பாயிண்ட் ஜி, ரைட்டா? ஸோ அப்போ இப்போ இங்கே ஜி பாயிண்ட்லாம் எப்படி மாற்றலாம்? ஜி ஈக்குவல் டு இ பிளஸ் 295 மைனஸ் 685 பிளஸ் 40 மைனஸ் 340 பிளஸ் 960 minus 270. So simplify, you will get just E value. Right? So this is after calculation of this, we will find the maximum fluctuation of energy. maximum fluctuation of energy. We know that the maximum fluctuation of D equal to maximum energy minus minimum energy. So in the value, so consider the value is maximum. இந்த விட்டுருங்க வந்து காமன் ரைட்டா. ஸோ மேக்ஸிமம் வேல்யூ ப்ளஸ் 295 தான் இருக்கு. வேற எதுவும் மைனஸ் 390 மைனஸ் 350 மைனஸ் 690 ப்ளஸ் 220 இதுதான். ஸோ அப்போ மேக்ஸிமம் வேல்யூ plus 295 இல்ல. ஸோ plus 295 minus minimum energy. Minimum energy, where is the minimum energy? So 297 positive. So minusல எது அதிகமா இருக்கு பாருங்க. minus 390 minus 350 minus 690. So minus 690 தான் is a very minimum energy. Lowest energy, minimum energy. So minus minus 690. So after simplify this, you will get 985 mm square. So plus 279. So minus c. Minus plus c minus c cancel ஆயிடும். ரைட்டா. plus c minus c cancel. அப்போ minus into minus plus 690. 690 plus 295 is equal to 985 mm square. Mm square. So mm square value we found that. Now okay, so 1 mm square now. So 1 mm square means what? Pi by 360, 5 by 36 Newton meter. So delta E equal to in terms of mm square, that is the energy. But if we want torque na Newton meter. So then we will convert into pi by 360. So 985 into pi by 36 is equal to 86 Newton meter is equal to or 86 joule. So 1 Newton meter is equal to 1 joule. Up 86 Newton meter na 86 joule. So now let us find the CS, coefficient of fluctuation of speed. Coefficient vandale C. Adala coefficient of means C. So coefficient of fluctuation of energy means CE, and the coefficient of fluctuation of speed means CS. So delta E. So what is the relevant formula for finding the C is coefficient of fluctuation for this formula is delta E equal to mk square omega square CS. So this is a relevant formula. So substitute delta E value. Just now we found that. So 86 joule, right? That is 86. Substitute that 86. So 86 is equal to m value is given, right? 36. K value 0.15 whole square given. Omega value 198.52 we found square. CS is unknown value. So after simplifying we will get CS value. So 0.003 or in terms of percentage 0.3 percentage. Clear? Anyone? Anyone? In the diagram base பண்ணி தான் ப்ராப்ளம் வரும். இது ரொம்ப ஈஸி. ஸோ பாசிட்டிவ் டாப்ல வந்தா ப்ளஸ், பாட்டம் பிலோவில் வந்தா மைனஸ். ஸோ ஒவ்வொரு பாயிண்ட்டுக்குமே ப்ரீவியஸ் பாயிண்ட் வந்து நம்ம ஆட் பண்ணிட்டே போவோம். எனி ஒன் கிளியரா?
Yes, sir.
Okay, good. So now similarly problem number 2, the turning moment diagram for multi-cylinder engine. Multi-cylinder engine has been drawn to a scale 1 mm equal to 600 mm, 600 Newton meter vertically, and 1 mm is equal to 3 degree horizontally. Horizontal means a crank angle, vertical means turning moment. So the intercepted areas between the output torque curve and the mean resistance line taken in order from one end are as follows. So plus 52 minus 124 plus 92 minus 140. So minus only bottom one. The diagram refer this diagram. So plus 85 minus 72 and 107 mm square. So when the engine is running at a speed of 600 rpm, so if the total fluctuation of speed is not to exceed plus or minus 1.5 percentage. So this is what already we discussed. Previous problem. Okay, plus one plus or minus 105 percentage means so the past in above 105 1.5 in bottom 1.5, totally 1.5 plus 1.5 totally 3. So omega 1 minus omega 2 equal to 3 percentage. The maximum fluctuation of speed does not exist to plus or minus 1.5 percentage of the mean speed. Mean speed no omega. So therefore 0.03 omega, right? So this is a concept. So find the necessary mass of the flywheel of the radius 0.5. So mass of the flywheel m only we are going to find out. So diagram. So value the n value is given. Speed value is given n, right? So from n from the n we using n we will find out the omega. Omega equal to 2 pi n divided by 60. 2 pi n value 600 divided by 2 pi n divided by 60 divided by 60. 2 pi n divided by 60. So simply after simplify, we will get 62.84 radian per second. So R equal to, so given value R equal to 0.5, radius value given 0.5 meter, radius value given, radius value given 0.5 given, right? So now coefficient of fluctuation speed C is equal to omega 1 minus omega 2 divided by 2. Omega 1 minus omega 2 value 0.03 omega. So divided by omega na, in the omega this omega cancel, so remaining 0.03. So the turning moment diagram. So since the turning moment scale is 600 into 3 degree. 3 degree means 3 degree now into pi by 180. It 3 degree Raja, 3 degree now number 3 degree in the we will convert into radian. So radian na pi by 180 multiply பண்ணணும். அப்போ இந்த 360 times போகுமா? So pi by 60. Pi by 60 radian. Pi by 60 radian. So therefore 600 into pi by 1 pi by 60. 600 into 600 into pi by 60. But simplify பண்ணா we will get 31.42 Newton. So now similarly let the total energy at E at A equal to E. Okay, va? So B equal to E plus 52, C equal to E plus 52 minus 124. Right? ஆமா இங்க இந்த பாயிண்ட்ல ஏ இருக்கு இல்லையா? அப்ப ஏ பாயிண்ட்ல எடுத்துட்டீங்கன்னாக்கா ஒவ்வொரு பாயிண்ட்டும் நம்ம கேல்குலேட் பண்ணணும். ஏ பாயிண்ட்ல இ இருக்கும், ஜஸ்ட் எனர்ஜி. ஸோ பி பாயிண்ட் வரும்போது ஆல்ரெடி ஏ பாயிண்ட் இ பிளஸ் 52 அதோட ஸ்டாப் பண்ணிடும். பட் கம் டு சி பாயிண்ட் வரும்போது இந்த இ பிளஸ் 52 மைனஸ் 124 அதை கேல்குலேட் பண்ணணும். மறுபடியும் டி பாயிண்ட் வரும்போது பிளஸ் இ பிளஸ் 52 ரைட்டா? ஸோ மைனஸ் 124 பிளஸ் 92 போகணும். புரியுதா ராஜா? அப்படியே ஜஸ்ட் ப்ரீவியஸ் வெளியே ஆட் பண்ணிட்டே போனோம். ஸோ ஃபைனல் பாயிண்ட்ல ஹெச் ஈக்குவல் டு ஜி ஈக்குவல் டு இ தான் வரும். ரைட்டா? ஸோ இந்த இ பிளஸ் 52 இ பிளஸ் 52 மைனஸ் 124 அந்த பிளஸ் 152 மைனஸ் 124 சிம்பிளிஃபை பண்ணால் யூ வில் கெட் இ மைனஸ் 72 வரும். அப்போ இதில் மேக்ஸிமம் எனர்ஜி இது, மினிமம் எனர்ஜி இது நம்ம கால்குலேட் பண்ணணும். மேக்ஸிமம் ஃபி பிளஸ் 52 தான் அது மேக்ஸிமமே. மினிமம் வந்து பார்த்தீங்கன்னா மைனஸ் 120. ரைட்டா? ஸோ திஸ் மினிமம் எனர்ஜி. ஸோ தட் த ஃபார்முலா we know that the fluctuation of energy delta, maximum fluctuation of energy delta equal to maximum energy minus minimum energy. Maximum energy E plus 52 minus minimum energy E minus 120. In the diagram E minus 120. So in this diagram value minimum energy நம்ம இது மாடுத்தோம் E minus 120, right? So E minus 120. அப்போ இந்த minus E plus E cancel. So plus 52 minus இந்த minus உள்ள minus plus ஆயிடும். So 52 plus 120, 172. 172, it is in terms of mm value. Sorry, in terms of mm square. But 1 mm equal to 31.42 na. புரியுது ராஜா? 31.42 வந்து இங்க ஃபைண்ட் பண்ணிருக்கோம் பாருங்க, சரியா? ஸோ mm ஸ்கொயர் வேல்யூ நம்ம கண்டுபிடிச்ச ஒரு டெல்டா எனர்ஜி மேக்ஸிமம் ஃபிளக்சுவேஷன் ஆஃப் எனர்ஜி இன் டெர்ம்ஸ் ஆஃப் mm ஸ்கொயர். அப்போ 1 mm ஸ்கொயர் ஈக்குவல் டு 31.42 நியூட்டன் மீட்டர்னா அப்போ 172 into 31.4 அந்த வேல்யூ இங்க கொண்டு வந்து மல்டிப்ளை பண்ணணும். 31.42 equal to 5404 Newton meter. So let's we find mass m equal to mass of the flywheel in kilogram. So what is the relevant formula? Delta E equal to mr square. So இங்க simple மா. இந்த ப்ராப்ளத்துல இந்த ப்ராப்ளத்துல ரேடியஸ் வேல்யூ கொடுத்துருவாங்க. ஸோ ரேடியன் ஆர் வேல்யூ நம்ம சப்ஸ்டிட் பண்ணிடும். ஸோ ப்ரீவியஸ் ப்ராப்ளத்துல ரேடியஸ் ஆஃப் ஜெனரேஷன் கே கொடுத்துருந்தாங்க. ஸோ தட் வி யூஸ் தட் கே. இந்த ப்ராப்ளம் ரேடியஸ் ஆஃப் த ஃப்ளைவில் கொடுத்துருக்காங்க. ஸோ டெல்டா இ வேல்யூ 5404 இங்கே கண்டுபிடிச்சிரும் பாருங்க. இதை சப்ஸ்டிட் பண்ணுங்க. ஸோ எம் வேல்யூ அதுதான் நம்ம கண்டுபிடிக்கணும். ஸோ ஆர் வேல்யூ 0.5 ஹோல் ஸ்கொயர், ஒமேகா வேல்யூ 62.84 ஸ்கொயர் into CS. CS value 0.03 is equal to totally to 29.6 meter. 29.6 meter. So sorry, 29.6 into m mass value, right? So இந்த வேல்யூ வந்து நம்ம என்ன பண்ணணும், டிவைட் பண்ணணும். ஸோ 5404 divided by 219.6 na 183 kilogram. The weight, the mass of the flywheel 183 kilogram. Clear? Anyone? Anyone clear? புரியுதா? நம்பர் வேற ரிப்பீட் பண்ணிட்டாங்களாமா? Anyone?
புரியுது சார்.
ஓகே ஓகே. இந்த டயக்ராம் தான் வரும். இந்த டயக்ராம் பேசிஸ் பண்ணிட்டு நம்ம சம் சால்வ் பண்ணுவோம், சரிங்களா? So next, a shaft fitted with a flywheel rotates at 250 rpm and the drives a machine. Okay, the torque of machine varies in a cyclic manner over a period of 3 revolutions. The torque rises from 750 Newton meter to 3000 Newton meter uniformly during half revolution and remains constant for the following revolution. It, it then falls uniformly to 750 Newton meter during the next half revolution and remains constant for one revolution. The cycle being repeated thereafter. Determine the power required to drive the machine and the percentage fluctuation in speed. If the driving torque applied to the shaft is constant and the mass of the flywheel is 500 kg with radius of gyration of 600 mm. Right? So actually what is given குடுத்துருக்காங்கன்னா ஓகேமா. So just a shaft fitted with a flywheel at 250 rpm. Speed value is given right? Speed value n equal to given 250 rpm. Clear? 250 rpm. Okay, the torque of machine varies in cycling manner over a period of 3 revolution. Right? So இங்க என்ன கொடுத்துருக்கோம்னா the torque of machines varies and the fluctuation torque varies in a cyclic manner over a period of 3 revolution. One revolution எத்தனை pi means pi means one revolution. Clear? Sorry, 5 means half revolution. 2 pi means one revolution. 1 pi என்றது எவ்வளோமா? 1 pi equal to 180. 1 pi equal to 180. அப்போ 180 means half revolution, half circle. கரெக்டா? அப்போ ஒரு complete 360 degreeனா one complete circleனா 360 degree. அப்போ 180 plus 180 அப்போ 2 pi சேர்ந்தா 1 revolution. அப்போ 3 revolutionனா totally 6 pi. இந்த கான்செப்ட் புரியுதுங்களா? anyone? லாஸ்ட் ப்ராப்ளத்தில் கொடுத்த மாதிரி தெளிவாக டயக்ராம் கொடுக்கல. ஸோ நம்மள தான் ட்ரா பண்ண போகிறோம். இங்கே அந்த டார்க் வந்து வேரி ஆகுது 3 ரெவல்யூஷன். ஸோ பட் நமக்கு தெரியணும் 1 ரெவல்யூஷன்னா என்ன? 2 பை. ரைட்டா? கரெக்டாக ராஜா? 1 ரெவல்யூஷன் மீன்ஸ் 2 பை. அப்போ அந்த பைன்றது என்ன ராஜா? 180மா. பைன்றது என்ன? 180. பையோட வேல்யூ 180 தானே? அப்போ 180ன்றது நான் 90ன்றது ஃபர்ஸ்ட் குவாட்ரண்ட், 180ன்றது 2 குவாட்ரண்ட் ஆஃப் சர்க்கிள், 270ன்றது தேர்ட் குவாட்ரண்ட். ஓகேவா? 360 4 quadrant. So the complete 2 pi. Right? 180 2 pi. So the torque rises from 750 Newton to 300 Newton meter uniformly during 1/2 half revolution. Half revolution means pi. Right? Half revolution means pi. How we are going to draw the diagram? So we only draw the diagram. We only draw the diagram. So the turning moment, it is a crank angle. Right? So it is 0. The torque rises from 750 to the torque rises from 750 to 3000 Newton meter during half 1/2 revolution. Right? So அப்போ இங்க இருந்துட்டு என்ன பண்ணும்? So 750 to 3000. அப்போ 750 எங்கமா இருக்கு? So 750. So sorry. So once again. Vertical axis turning moment and horizontal axis crank angle. So here 0. Here 0. Okay, 0 to in this level 750. Okay, this level 750 and this level 3000. Mark in the graph 3000. Is that clear? So அப்ப என்ன சொல்லிருக்காங்க அந்த क्वेश्चन என்ன சொல்லிருக்காங்க பாருங்க. So the torque rises from 750 Newton meter to 3000 Newton meter. அப்போ torque rises from 7. இப்போ அந்த 0 to 150 வரைக்கும் ரேஸ் ஆகல ராஜா. அமைய சைலண்டா ஒரே டார்க் லைன்ல வருது. பட் 750 வந்ததுக்கு அப்புறமா 750ல இருந்து 3000 வந்து என்ன ஆகுதுன்னா ரைஸ் ஆகுது. டார்க் ரைசஸ் ஃப்ரம் 3 ரெவல்யூஷன் ஃபார் தி ரெவல்யூஷன். அப்போ இதுவரை ரெவல்யூஷன் ஆகுதுன்னா அப்போ இந்த இது நம்ம ஐயா என்ன இங்க என்ன சொல்லியிருக்காங்க? ஆஃப் ரெவல்யூஷன் தான் அது வந்து என்ன ஆகுது? கரெக்டா? it is only half revolution மட்டும்தான். It is during half revolution and remains constant for the following revolution. ஓகேவா? Then it falls uniformly to 750 Newton meter during the next half revolution. Okay, it is remains constant இல்லையா? Remains constant for the following revolution. அப்போ it is constant. ஓகேவா? constant. ரைட்டா? constant for the following revolution. அது எவ்வளோ ரெவல்யூஷன் கொடுக்கல, ஜஸ்ட் ஃபாலோயிங் ரெவல்யூஷன் கொடுத்துருவோம். Then it falls uniformly 750 Newton. Some form falls 750 Newton falls to during next 1.5. So for a particular constant, then again it will falls to 720 Newton வருது. 750 எங்க இருக்கா? So 750 இங்க வருது. ரைட்டா? இங்க வந்துருது. ஸோ அப்போ இங்கிருந்து வருதா? ஸோ இங்கிருந்து தான் நமக்கு ஃபாலோ ஆகுது. ரைட்டா? இங்கிருந்து ஃபாலோ ஆகுது. அப்போ இதனோட பை நமக்கு இன்னும் தெரியாது. பட் இங்க இந்த ஒரு வேல்யூ இருக்கு இல்லையா? இது ஸோ இது புரியுதா இப்போ? ஓகேவா? ஸோ 120 during next half revolution and remains constant for one revolution. Remains constant for one revolution. Remains constant for one revolution. எங்கம்மா? Remains constant for one revolution. The cycle being repeated thereafter. ரைட்டா? ஸோ இப்போ ஃபார்முலா ஒன்று பார்த்தீங்கன்னா, ஸோ அகைன் இங்க இருந்துட்டு ஒரு ரெவல்யூஷன் போதுமா? ஸோ தட் இது ஒரு பை. ஸோ இங்க வந்து பார்த்தீங்கன்னா இங்க 2 பை, இங்க 3 பை. This is 4 pi. Here 5 pi. Here 6 pi. Right? So just a mark it. So here A, B. So similarly, so the come to the point. So given n equal to 250 rpm. So r omega equal to 2 pi. So n value given la. So 2 pi n value 250. 250 into divided by 2 pi n divided by 60. 2 pi n value substitute 250 divided by 60. So 26.6 radian per second. Mass equal to 5,000 kilogram. Okay, K radius of gyration K value 600 mm. So 6.0.6 meter. Okay, so we know that the torque required for one complete revolution or a complete cycle is equal to area of figure. So in this figure, so 0 to 0 to 752 raising from 7 torque raising from 750 to 3000 for half revolution. So half revolution is up to pi. So it is constant for a particular pi, but one revolution, that is a 2 pi. Again it falls from 3000 to 750 at remaining half revolution from 3 to 4 pi half revolution. So remaining constant for one revolution. This is a 5 pi, so one revolution. So 4 5 5 to 6 2 pi into one revolution. கரெக்டுங்களா? ஸோ மார்க்கெட் ஏ பி சி டி இ எஃப் ஜி ஹெச் எம் என். ரைட்டா? ஸோ இது மட்டும் தான். அப்போ நமக்கு மேக்ஸிமம் 3000 லைனும் 750 லைனும் தெரியும். பட் நமக்கு வந்து மீன் லைன் தெரியணும். ரைட்டா? ஸோ இட்ஸ் நெசசரி டு ஃபைண்ட் தி mean line. We don't know on the crank position. Based on crank position, we plot the diagram. But it is mandatory to know the we find the mean line. So 1875. So how this 185 came, right? So this is what concept. So now area of figure OA, OA B C D E F. கரெக்டுங்களா? ஸோ வர்றஜா பாருங்க, OA B C D E F அந்த கம்ப்ளீட் ஆங்கிள் தான் நம்ம பார்க்கணும். சரிங்களா? So area of figure A, OA, B, C, D, E, F. So first the triangle OA, EF. OA, EF. So O எங்கம்மா இருக்கு? பாருங்க, O, A, E, F. இந்த 4 triangular. அப்ப இந்த rectangular now what is the formula of L into B ல? So L into B. அப்ப இதோட B வந்து B வந்து 750, L வந்து 65. L வந்து 65. ஸோ இந்த ஃபார்முலா OF into OE அந்த ஃபார்முலா சிம்ப்ளிஃபை பண்ணுவோம். ஏரியா ஆஃப் ABG. ABG இஸ் நத்திங் பட் வேர் இஸ் ABG ABG ரைட்டா இந்த ரெக்டாங்குலர். அதே மாதிரி CHD இந்த ரெக்டாங்குலர் ஃபார் ட்ரையாங்குலர் ட்ரையாங்குலரோட ஃபார்முலா நம்ம ஆஃப் BH. அப்போ ஃபார் இந்த ABH ஃபார்முலா எடுத்துக்கோமா இந்த டயக்ராமில் நீங்கள் எக்ஸாம்பிள் ட்ரையாங்குலர் ABG எடுத்துக்கோங்க. ABG எடுத்துக்கிட்டா வாட் இஸ் த ஏரியா ஃபார்முலா ஆஃப் இன்ட்டு B ஆஃப் BH இல்லை ஆஃப் BH B வேல்யூ AG ஆஃப் இன்ட்டு B வேல்யூ AG இன்ட்டு BH H வேல்யூ BG H வேல்யூ BG இதுதான் எங்க கொடுத்துருக்காங்க சரிங்களா. இஃப் ஆஃப் இன்ட்டு AG இன்ட்டு BG அதை நம்ம சால்வ் பண்ணோம். ஆஃப் இன்ட்டு AG இன்ட்டு BG. அதே மாதிரி இப்போ CHD இந்த ட்ரையாங்கிள் இருக்குன்னா ஆஃப் இன்ட்டு BH ஆஃப் இன்ட்டு BH வேல்யூ HD and H value CH. HD and CH into A BCH ஓட ஃபார்முலா L into B. So BCH எதுங்க BCHG எங்கம்மா இருக்கு BCHG பாருங்க BCHG. அப்போ இதோட இது வந்து ரெக்டாங்குலர். அப்போ ரெக்டாங்குலர் ஃபார்முலா L into B. L வேல்யூ இந்த வேல்யூ எவ்வளோமா 2π into GH into BG GH into BG GH into GH into CH ரைட்டா GH. ஸோ அப்போ இதெல்லாம் சிம்பிளிஃபை பண்ணும்போது ஸோ OAF 6π into 750 1/2 π into 3000 minus 750 so plus 2π into 3000 minus 750. Once simplify we will get to 11,250 11,250 into pi Newton meter. So if the T mean is the meter Newton meter, then torque required for one complete cycle. So T mean equal to T mean into 6π. T mean into 6π Newton. So complete one revolution எவ்வளோமா 6 maximum level 6π இருக்கு. T mean into 6π. So now T mean equal to 11,250 divided by 6π equal to 1875. இதான் அந்த 1875 ரைட்டா. ஸோ இந்த 1 is the mean. ஸோ இந்த மீன்ல இருந்து நம்ம என்ன பண்ண போறோம் maximum fluctuation of energy கண்டுபிடிப்போம். Maximum fluctuation of energy. So power required to drive the machine. So we know that the power required to drive the machine P equal to T mean into omega. So T mean value 1875 into omega value 26.2. So totally P value 49,125 watt. So in terms of kilowatt, so 49.125 kilowatt. Now we are going to find out coefficient of fluctuation of speed. Let so C is equal to coefficient of fluctuation of speed. Coefficient of C is equal to C means coefficient. S merely fluctuation of speed. Now the power required to drive the machine P equal to T mean into omega and the formula value given. Power value கேட்டிருக்கணுமா sorry determine the power required to drive the machine கொடுத்துருக்கீங்களா determine the power. So அப்போ the power formula வந்து பார்த்தீங்கன்னா the power formula so P equal to T mean into omega. T mean 1875 into omega value 26.9 26.2. So finally we will find out 49,125 watts. So now coefficient of fluctuation of speed C is equal to so it's a similar triangular in the similar triangular okay was similar triangular so A triangular ABH ABH and BLM அப்போ LM divided by AG is the same distance ரைட்டா is a similar ரைட்டா so LM divided by AG is equal to BM divided by BG. So now LM AG ஓட வேல்யூ பை ரைட்டா. இந்த டயக்ராம் பார்த்தீங்கன்னா உங்களுக்கு தெரியும் AG ஓட வருமா AG இருக்கு இல்லையா இந்த AG ஓட வேல்யூ பை வருங்க. இந்த AG ல இந்த டிஸ்டன்ஸ் தான் AG. அப்போ AG ஓட வேல்யூ 0 to pi. Pi value தான் அந்த AG. ரைட்டா? So AG equal to pi is equal to BM value 3000. BM value 3000 substitute பண்றான். எப்படிமா? BM value. So B எங்கமா இருக்கு? So BMல இந்த BM value இது கண்டுபிடிக்கணும்னா அப்போ 3000 BM value 3000 minus 1875. 38,000 minus 1875 minus பண்ணா அந்த BM value கிடைச்சிடும். divided by BG value. BG value எங்கமா இருக்கு? BG இல்ல. So அப்போ 3000 minus 750. 3000 minus 750 னா BG. ஸோ BG வேல்யூ நமக்கு இங்கிருந்து இருந்தாலும் வேணும். ஸோ அப்போ நம்ம BG வேல்யூ தெரியாது. அப்போ இந்த 0 to 75 இந்த 750 மைனஸ் போக இந்த வேல்யூ தான் நமக்கு BG. ரைட்டா? ஸோ அப்போ 3000 minus 750. So equal to simply once after simplify we will get 0.5. After simplify we will get 0.5. 0.5. So now LM equal to 0.5 meter is 0.5 pi. So now similar to similar triangle CHT and CNP. So here in this side, okay. So this CNP HD, CNP CHD. So same procedure we will follow and find the NP equal to 0.5 pi. So BM equal to, so total this value, and D equal to area of LCB. The value in the area of LBM plus area of MCBN plus area of PNC of into LM into BM plus MN in the area of MBC MN into BM of NP into C. So once substitute all the values and finally find the 8,837 Newton meter. There is a torque. So now maximum this is a energy fluctuation. Delta E equal to mk square omega square cs is equal to, so m value 500. So k value omega value cs value. So finally cs equal to 0.071 value. Right? So this is also same method. So the suction, compression, expansion, exhaust. Right? The position of crankshaft. Now consider the now consider position of the crankshaft. So same method. The turning moment diagram for four-stroke gas engine may be assumed for simplicity to be represented by four triangles. The areas of which from the line of zero pressure are as follows: suction stroke, so 0.45 into 10 power minus 3 meter square, and a compression stroke 1.7 into 10 power minus 3 meter square, and expansion stroke 6.8 into 10 power minus 3 meter square, and exhaust stroke is equal to 0.65 into 10 power minus 3 meter square. So each m square of the area represent 3 Newton meter of the energy. So assuming the resulting torque to be uniform, find the mass of the rim of flywheel required to keep the speed between the 202 and 198 rpm. The mean radius of the rim is 1.2 meter. So the section stroke A1, A2, A3 and A4 is given. So N1 equal to 202 rpm and N2 equal to 198 rpm and R radius equal to 1.2, radius R equal to 1.2 meter. So net area, so A minus A3 only positive. Right? So in this diagram, so A1, A2, A3, right? And this is A4. So A1, A2, A3, A4. A3 only positive plus. So remaining all minus. So that A3 only, so that A3 only plus. So minus of A1 plus A2 plus A3. So simplify, you will get 4 into 10 power minus 3 meter square. So but since the energy scale is given by, so 1 meter square is equal to 3 meter 3 mega Newton meter. So since the energy scale is 1 meter square is equal to 3 mega Newton meter, equal to 3 into 10 power 6 Newton meter. Therefore, one second, ma. Okay, ma. So energy scale is 1 meter square would 3 mega Newton. Mega value 10 power 6. Kilo na 10 power 3. Mega na 10 power 6. Giga na 10 power 9. Okay, so mega value, so 10 power 6 into Newton meter. So upon total net energy 4 into 10 power minus 3. 4 into 10 minus 3 now into 4 into 10 power minus 3 into 3.10 power 6 into 3 into 10 power 6. So total 12 into 10 power 3 Newton meter. So our net work done per cycle T mean equal to 4 pi Newton. So total pi 4, total value up to 4 pi la. So up to that we consider the work done. So T mean equal to T mean into 4 pi. So finally T mean equal to Fg equal to 12 into 10 power minus 3 divided by 4 pi. Enter. So we got 955 Newton meter. So this is a value. And finally, similar uh, as previous problem. Okay, so on the based on triangles, we will find the fluctuation of energy. Right? So finite one dimensions of flywheel rim. So tensile stress or hoop stress sigma equal to omega rho r square omega square or rho v square. So rho equal to density. Rho means density of the rim material in kilogram per meter cube. So n equal to speed of the flywheel in rpm and omega equal to angular velocity of the flywheel in radian per second. V equal to linear velocity of the mean radius in meter per second. Uh, v equal to omega into r. So equal to dn divided by 60. Right? So similar mass of the rim m equal to volumetric density. So volume rho into dA. So if the cross section of the rim is a rectangular, then A equal to B into T. Okay, B into T, where B equal to width of the rim and 3 equal to thickness of the rim. So the turning moment diagram value, given value now. So here, okay, over now. So speed value given omega equal to 2 pi into 800 divided by 16. So omega speed value is given ma. So from that we will find omega and stroke 300 mm and 6 equal to 7 megapascal. Mega na 6. 7 into 3 6 Newton per meter square. 1 pascal equal to 1 Newton per meter square. So rho density equal to 7200 kilogram per meter cube. Right? Okay ma. Tomorrow we will continue ma. Clear? ஓரளவு புரியுதாம்மா? Anyone? Ma, anyone?
Yes, sir.
Tomorrow. Thanks, ma. Tomorrow we will continue.